Today we are going to talk about the identity element under binary operation. Alright, so when we talk about the identity element, we see that if E, which belongs to the set of real numbers, alright, is the identity element under a binary operation, let's say star, on a set R of real numbers, then A, which is a certain number from the set of real numbers, operation E, is equal to E operation A is equal to A. Alright. Then when we combine any number or a certain number A with the identity element E, or when we combine the identity element with a certain number, we should get that same number. Alright. So in basic terms, what we are saying is that, for example, if you have a number like 2, alright, and you choose the operation, let's say addition, alright, if you combine this number 2 and then the identity element with addition, you should be getting the same number 2, alright. If you combine the number 2 and the identity element with the operation addition, you should get the same number 2. So what number do you think we are going to add to 2 to get the same number 2? Good, your guess is right. The number is what? 0. So our identity element in this case is what? 0. Good. Another example, if you have 5, alright, 5 plus what number will give you that same number 5? The number is what? 0. Alright. Good. So in this case, we say that the identity element and the addition of real numbers is 0. In any case, or in short, we can say the additive identity is what? 0. Okay, because the number that you add to any number to get the same number is what? 0. So in this our case, our identity element is what? 0. Alright, good. Another example, let's say if you pick the number 3, alright, and then you want to choose the operation multiplication, what number are you going to multiply by 3 to get the same number 3? We know that the number is what? 1. You see that? Good. Then also if you pick, for example, the number 4, what number will you multiply by the number 4 to get that same number 4? The number is what? 1. Good. So in this case, we say that the identity element under multiplication of real numbers is what? 1. Okay, simply because the number that you multiply by any number to get the same number is what? 1. So if you multiply 4 by 1, you get the same number 4. 3 by 1, you get the same number 4. So the identity element in this example is what? 1. Is that right? So when we talk about identity element, what we're trying to say is that, for example, assuming E is the identity element, then if you combine any number and the identity element with an operation, or if you combine the identity element and any number with an operation, we should get what? The same number. That's what we're saying. So over here, if you combine the number 2 and the identity element 0 with the operation plus, you're going to get the same number. Over here, if you combine the number 3 and the identity element 1 with the operation multiplication, you're going to get what? The same number 3. Good. So now let's look at some simple examples and binary operation. Good. Our first example says that an operation is defined on the set R of real numbers by A star B is equal to A plus B minus AB, where the numbers A, B belong to the set of real numbers. Now we are asked to find the identity element. We want to find the identity element. So we are saying that we don't know the identity element, so we let E, which is a real number, be the identity element. Okay, let E, which is a real number, be the identity element. Now what we are saying is that anytime you combine any number with identity element, you should get the same number. All right, good. So we can say that if we combine the if you combine A and then the identity element E with the operation star, we should be getting that same number, what? A. Alright, good. We're going to use the define operation to evaluate this and then find the identity element. So our A is what? A, and then our B is what? E. Is that right? Good. So wherever we find A, we put A. Wherever we find B, we put E in the definition. So we would have A plus B. Our B is what? E. E. Alright, this is E. Good. Minus A, our B is what? E. Okay, is equal to A. Good. So now we'll find the E, which is our identity element. So in doing that, we have E, so this is E, E minus AE is equal to A, and then I'm trying to group terms, so the A will come here minus A. Good. Now the common factor in the two terms on the left side is E, so you factor the E out, you're left with 1 in the first term, minus you're left with what? A over here. This is equal to A minus A is what? 0. Now our identity element is E, so we are looking for E. You divide through by 1 minus A by 1 minus what? A, so that this one will cancel this one. Is that right? Good. Therefore our identity element E is equal to 0 over 1 minus A, which is the same as what? 0. Good. So that is our identity element. Good. Let's look at another example. Example 2. This time we said a binary operation triangle is defined by P triangle Q is equal to P plus Q plus the square root of 5 on the set R of real numbers, where PQ belongs to the set of real numbers. And we have to find the identity element E. Alright, under the operation star. Sorry, under the operation triangle. Good. Sorry for that. So let's look at the solution. Now what we know is that when you combine P and then the identity element with the operation triangle, we should be getting that same number, what? P. Per the definition over here. We combine a number and then the identity element, you should be getting that same number. Good. So now per our definition, our P is P, and then our Q now is what? E. So in a definition, where we find P, we put P. Where we find Q, we're going to put what? E. Whatever we get is equal to P. So now we have P plus a Q is what? E. So E plus the square root of 5, is that right? Is equal to P. Now our identity element is what? E. So we solve for what? E. Now we have E plus the square root of 5 is equal to P. Then we group in terms, so the P will come here, I guess minus P. Now we want to find the value of E. So we have E plus the square root of 5 is equal to P minus P is what? 0. Now we can make the E to stand alone. So we have E is equal to the one crosses and you get negative square root of what? 5. So that is our identity element. That is our identity element. So what we are saying is that anytime you combine the identity element and then any number with an operation, you should get the same number. Or if you combine identity element and any number using a defined operation, you should get the same number. Now let's take another example. This one says that the operation star is defined on the set T. It contains these elements by the table below, this table we have over here. And the question is saying is that from the table, you should determine the identity element for the operation. We should determine the identity element for the operation. Good. Now, when you look at the table, or what we know, the identity element is such that if you combine the identity element and a number with an operation, you should get that same number. Good. So we are going to look into the table and then determine or find our identity element. Now, this is what we are going to do. We're going to pick the element we have in the column over here. Okay, each of them approaching the
elements in this row and see the answers we'll be getting.
Good. So now, when you look at the table, A operation what element is giving us the same element A. Now what we are saying is that anytime you combine the number, for example A, with the identity element, you should get that same number A. If you combine B and then the identity element E with the operation, you should get the same B. If you combine C and then the identity element E with the operation, you should get the same C. Is that right? Good. So now you're saying that A operation, which element is giving you the same element A? Then also B operation for the element will be giving us the same B, and then C operation or element is going to give us a C itself. So when you look at the table, this A is the A you have over here, right? This A you see over here is the A you have over here. The A over here. So you see that A operation A is giving us the same element A, right? So it's like this A you see over here, or the A you have over here, is the A we are having over here. Is that right? Good. And so you realize that A operation A is giving us the result A, right? So you have A operation A giving us A. A operation A is giving us what? A. Now if you come to the B, this B you see over here is a B over here. The B over here is a B over here. So this B operation what element, or operation which element will give us B? You realize that you have B operation A giving us what? B. B operation A giving us what? B. So B operation A will give us what? B. Then the C you see over here is the C we have over here. The C you see over here is the C we have over here. So now C operation what is going to give us C. Now I'm giving you 3 seconds to find the answer. Good. So now you have C operation A giving us what? C. So C operation A is what? C. So you realize that the identity element E, right, is what? A. You realize that A operation, the identity element is giving us A, and so A operation A is giving us A. B operation, the identity element is giving us what? B. So you have B operation A giving us what? B. C operation, the identity element will give us C, so you have C operation A giving us what? C. Therefore we can say that the identity element is what? A. Is that right? Good. Therefore the identity element is what? A. Good. Let's take the last example. Okay, let's take the last example. This one says that a binary operation is defined on the set S, which contains this element, by the following table, by the table we have over here. Good. Now we are supposed to show from the table whether or not there is an identity element. Alright, good. So we should think of trying to see or check whether we have an identity element. Alright, now what we said is that anytime you combine the identity element with any number, we should get the same number. So let's assume that the identity element is E. So what we're saying is that if you combine the identity element E, operation the element P, we should be getting what? That same P. If you combine the identity element and Q, we should get what? That same Q. The identity element E, operation R, we should get the same R. If you combine the identity element E, operation S, we should be getting that same S. Alright, so you can start to bring the P first. Maybe P, operation the identity element E, should be getting the same P, the same thing anyways. Alright, so now we are going to check from the table and find the identity element E. Alright, so now from the table, what element and then P can be combined with the operation to get the same P. And then what element and then Q are being combined with the operation to get the same Q. Then again, what element and then R are being combined with the operation to get the same R. And then what element and S are being combined with the operation to get the same X. Alright, now this time you have these elements over here being the elements in the row over here. The one we want to find over here would be from the column over here. Good. So now when you look at the table, okay, what element over here, operation P, will give us the same P. So you see that R operation P is giving us what? P. Okay, so R operation P is giving us what? P. So that to be R. Good. Then when you come to the second part, now we have this one. The Q over here is a Q over here. Can you see that R operation Q is giving us what? Q. So this one is R. Now when you come here to, you see that you have R operation R giving us what? R. R operation R giving us what? R. So this one is R. And then the last one, you have R operation S giving us what? S. So this one is what? R. See that? Good. So therefore, the identity element is what? R. Okay, the identity element is what? R. You could also have done it this way, like this. You can decide to do it like this, and see that P operation what number or what element is going to give you that same P, and Q operation what element or which element will give you the same Q, R operation which element will give you the same R, and then S operation which element will give you the same S. In this case, the P, Q, R, S, or the elements you have over here are the elements in the column over here. Alright, and the identity element you want to find over here will be in the row over here. Good. So you realize that P operation R will give you the same P. So this one is what? R. When you come here to Q operation R will give you that same Q. So this one is what? R. Then again, R operation R will give you what? R. This is R. And S operation R will give you what? S. So this is R. Alright. Then you can conclude that therefore the identity element is what? R. Alright, there's also something I need to talk about. You see that the arrangement we have for the element over here, P, Q, R, S, that is the same arrangement we have over here, P, Q, R, S, right? P, Q, R, S. I should tell you that the element over here is the identity element. When you look at this one, P, Q, R, S, P, Q, R, S, you have over here to P, Q, R, S. So the arrangement over here is also the same as the arrangement you have over here. It means this element over here is identity element. Likewise, in the first example, you'd also notice that the arrangement you have over here, A, B, C, as the same arrangement, A, B, C, like this. Alright, good. It means this is the identity element. When you come here to A, B, C, you have A, B, C, right? It means this is the identity element. Alright, so you only have to study the table and then be able to figure out the identity element. In the next video, we're going to talk about the inverse element of binary operations. Stay tuned.